Okay.
So we know this is a even degree polynomial and it's positive, right? So there we go. That's going to be the sketch.
Okay.
So now we just connect the dots, okay? But now be careful here. What matters is something called the multiplicity, okay? Multiplicity, another word is order. So what matters is the multiplicity or the order of factors. You see this one at negative 2.5? Yeah?
Yeah.
The multiplicity is 1, so it's gonna go through it. It's gonna cross through it. But then notice the x squared has a multiplicity of 2. So if the order is 2, what that means is that there's gonna be a parabola or a turning point at that x-intercept.
Mm-hmm.
So this one has a multiplicity of 2. That's why there's a turning point at the origin. And then finally, what's the multiplicity of this one?
3.
So 3, that means it's going to act as a cubic function, okay? Multiplicity 1 means a linear function, so it's going to be a straight line at that. Power 2 means it's going to be like a parabola at that.
Like
And power 3, yeah, power 3 means it's going to look like a cubic function. So at 0.75, yeah, it's going to look like this. Because this is 0.75. It's going to look like a cubic function, okay? So I'm going to try my best to draw this here, but so it's going to be a little bit scuffed, but yeah. So if you zoom in here, that's what it should look like.
And how do I know? Like, I had another question, like relating to last unit. How do I know if there's like if it's being compressed or something? Like, where would that value be?
It won't be in this, not in this form. This is the
That
factored form. Yeah, to see the compressions, you have to be in the vertex form of a cubic or whatever.
Wait, say like you just have like 4x cubed minus 12x squared minus x plus 3.
Yeah, then it will be 4.
Then it's 4.
Mm-hmm.
What do the other numbers represent though? I know 3 is the y-intercept, right?
Yeah, well, they just represent how up and down these mini curves are.
Okay. And here you'd still find like maximum and minimum the same way, right?
Yeah, the same way, yeah. If they ask you. The book doesn't ask you though, your teacher does.
Yeah, I don't know why. He just said like to be more accurate when you're graphing.
Right, you can always Desmos this as well.
Yeah, but on the quiz, I don't think I can Desmos it. Okay, so another thing, let me get the page. If you go to page 58, 59, and 159 and 160, like that's like the part he said to review for the quiz.
Wait, page 58, 59?
58, 59, that's the first part. So he said like reread those, and then the questions are in 62.
You wanna do this?
Is there anything with graphing in this?
Yeah, but this is pretty simple. This is just the chapter 1 stuff. There's no cubic in this.
If there's no like cubic, I'm good. And then he also said 159, 160.
So yeah, these are just the parent functions. There's no cubic in chapter 1.
Okay, if it's just parent function, like probably good.
You said 159?
Yeah.
Yeah, 159, 160 is the cubic ones, the cubic quartic ones. Do you want to do this? Questions on 161?
What's up? Yeah, 161. We could like do like a few.
This is it, right? What the test covers?
The
quiz, whatever, yeah. Does it cover 3.5?
He just said like lesson 2.1 to 2.5. So like the last thing we covered was solving polynomials.
So no dividing, right? No dividing polynomials.
No, we did do dividing polynomials too.
Oh, you did? Because that one's a little bit tricky. Here, let's just speed run this, okay? It's very simple. It says polynomial or not. So for something to be polynomial, you see this? X to the power of n.
Mm-hmm.
The n has to be greater than 1, or actually has to be greater than 0, okay? The exponent must be greater than 0, cannot be negative. This is what that means. And it must be a whole number. So that means is that in the exponent, that number can only be positive integers.
Okay.
Only here, positive integers allowed. X, the coefficient here can be anything, right? The coefficient, we're not talking about the coefficient. We're talking about the exponent, okay?
The
Positive
exponent, I thought we were talking, I thought it was just like one value of X gives you one value for Y.
Yeah. But here what we're talking about is whether something is polynomial or not. Here, look at A. You see the powers? They're all positive whole numbers, so A is a polynomial.
Oh, that's what polynomial means?
Yeah.
So then the other one's not.
No. What about this one?
This one is?
Yes. Again, the root 10 is a coefficient. We don't care about that. We're looking at the exponents.
And then the other one is?
No, it's not.
It's not?
No.
Oh, because it's actually 2 over 1 or 3 over 1.
Yeah, this is a rational function. It's not a polynomial.
Why is that not a polynomial?
Because it's two different terms being divided by one another. Polynomial only has, polynomial is something in this form, ax squared plus bx plus c. See, if you divide by something, then you get something entirely. That's not a polynomial. Because this one actually, how do I know that? Here, there's a restriction, right? Polynomials don't have any restrictions on the x, but here x cannot be 2.
Okay.
Polynomials don't have any restrictions, so D is not a polynomial.
All right. That makes sense.
Yeah, these ones are pretty simple as well. It just says, give an example that has the characteristics described. I mean, function 3 that has 4 terms, so 3x cubed plus 4x squared plus 5x minus 4. This is pretty simple, yeah. I think you can conjure up these.
Okay, degree 2 has 4 terms. Yeah.
Yeah, so this one has 3 terms, so you can just say 4x4 plus 3x3 minus 5 or something. There you go. 3 terms.
Oh.
Then there's an infinite number of answers. This one's very simple. Whereas this one, it says state the end behaviors of each.
I don't even know if I learned that.
So it just means this. As x is going to positive infinity, where's y going? When x is going to negative infinity, where's y going? As x goes to positive infinity, where's y going?
Okay, but how would I know from the just like the equation?
Yeah, so this is a negative cubic, right? Negative cubic looks like this.
Yeah, true.
So as x goes to negative infinity, where's y going? Y is getting bigger and bigger and bigger. Y is going to positive infinity. As x goes to positive infinity, y is getting smaller and smaller and smaller. Y is going to negative infinity.
Okay.
And that's it. So for an odd degree function, the end behaviors will be the opposite for the y. So the signs will flip for an odd function, but for an even function, you'll see the end behaviors will be the same. Again, for end behaviors, you're always going to have x equals negative infinity and as x goes to positive infinity. So let's look at B. For B, it's a positive quadratic, right? Y is going to be going to positive infinity on both instances. So for an even polynomial, these two will be the same.
Okay.
Look at C, yeah. So
the same, and then for odd, it would just be the
yeah, the signs will be opposite. Yeah.
Opposite, okay. And then for the negative even, you would just do what?
Yeah, so negative even would be something. Let's just put a negative sign here, right? So a negative even would be going like this. So y will be negative infinity on both sides.
Okay, yo, if you don't mind, can we try graphing D?
Yeah, that one is well, we have to factor it to graph D because it's not in the factored form.
Yeah, like, so what's like the fastest way you could factor though?
Yeah, you need to guess and check factors of 5 in there as x.
But what do you do again when there's a negative 13 on the start?
That doesn't really have anything to do with this. So for this question, right? For this question,
You have to divide that.
yeah, you have to, but you don't have to do it for this question because it just says state the end behaviors. So it's a negative degree 4 function. It's going to start here and it's going to end here.
Mm.
Okay, so for this question, you don't have to do that. If you want to know how to graph it, let's do a question that relies us.
Like, I don't think they probably asked me to graph something like that. Probably. Sounds kind of weird.
Yeah, we have to do long division. It becomes a little bit difficult.
Yeah, like today we were doing like factoring, and we've been doing like long division the whole time.
Have you been doing synthetic division?
Yeah, I've been doing synthetic too.
All right, here we go. This is how you, so look at the equation, yeah? So the question is, how do we graph this, right? So here they've already given us a number. So usually you want to guess and check numbers, the factors of 5 in here as x, okay?
Mhm.
To get the factor, but here they've already given us. So that means if you're using synthetic, you're gonna have a -7 as the divider on the outside.
And then you got 1, 7, 2, and -5.
Yeah, 1, 7, 2, and -5. The 1 comes down as it is.
Mhm.
Then you want to multiply 1 with -7, it becomes -7. Add them up, 0, 0, 2, yeah?
Mhm.
And -7 times 2 is -14. Add them up, -19 is the remainder.
So then, how would that help you in graphing?
So here, since we have a remainder, right? They won't ask you this question. A graphing question will always have a remainder of 0. Here, let me do another one, a more
That's what
difficult.
I thought. I was also thinking, like, what does the remainder do when you're graphing?
No, there will be no remainder. There should be no remainder. If they ask you to graph it, then there is usually no remainder. Otherwise, it's not doable by hand. Let's look at this one. So again, it's a cubic polynomial, but notice how here we don't have anything to plug in as x.
Mhm.
So what do we do?
So for this one, you have to find the factors of 24.
Correct. So there's a bunch of them, yeah? Plus minus 1, plus minus 2, plus minus, oh, this one has so many.
But yo, how do I do it if there's if say like the x is like a 6?
Well, here?
Yeah, like right there. What would I
No,
do?
no difference. Literally nothing changes. You just guess and check everything in here as x.
But you're telling me that I don't do 24 divided by 6.
No.
Where have I seen them before? I sure I seen them before.
I mean, what happens in that case is, look at this. If you do 24 divided by 6, you'll just be looking at factors of 4, right?
Mhm.
So you'll be checking for these anyways, and these are already included here.
Oh, but you wouldn't have to do like the other ones.
Yeah, the 3s, right? You don't have to do that. But here there's nothing in front, yeah? So we're just gonna check with all of them. This one's gonna be a little bit annoying.
Yeah, this is I hate doing this.
I'm gonna cheat because I'm lazy. Especially for like an assignment question, right? We can always plug things in, but sometimes it will take us all the way to 8, and I don't want to do that. 5x squared plus or minus 2x plus 24. Minus 2x plus 24. Okay, so minus 2 works. So what we do here, yeah? I'm gonna say this is f of x, okay? This entire thing is f of x. I'm gonna try f of 1. Ooh, that did not work. Because 1, if you plug 1 in here, that doesn't give you a 0. I'm gonna plug -1 here, that doesn't work either. I'm gonna plug +2 here, that doesn't work. Finally, -2 works. Okay?
Is that like the factor theorem?
Yeah, it is the factor theorem.
Like what is the factor theorem really? Is it just like the a value is the remainder? I don't understand, or the remainder theorem. I don't really understand it.
It's this, okay? So remainder theorem tells you if you have some polynomial f of x, this is the remainder theorem. You have some polynomial f of x, You're dividing this by some polynomial x minus k. Okay.
Mhm.
Then f of k is the remainder.
F of x, and then you have k. K
So
is the remainder.
for example, if f of x is 3x squared plus 2x minus 5, yeah? And then
Mhm.
you're dividing this with x minus 5, then the remainder is given by f of k or f of 5.
Oh, if you sub in 5,
Yeah,
that's the
exactly.
remainder.
Yeah, that's the remainder. Okay.
Mm. Then how come people? So then, is that why people are trying to find the remainder that is 0 when you plug those in?
Yeah, so so that has to do with the factor theorem, which basically says this thing, right? And factor theorem says that if f of k, same thing, right? Same rule applies, okay? You're doing this. And if f of k is 0, then x minus k is a factor.
That's the theorem. That's all.
That's the factor theorem. Yeah, the one in green is the factor theorem. The one in blue is the remainder theorem.
Oh yeah. Okay, so after you find that -2, can
Yes,
you just do long division
synthetic is easier. Yeah, you can
or
definitely do long
synthetic?
division. Yeah. So we know -2 gives us a 0. So we know that x plus 2 is a factor. Yeah.
Mm-hmm.
X plus 2 is a factor. So we're
Yo,
gonna
when can I not do synthetic?
you can't do synthetic when the divisor is non-linear.
See, so like it can only happen in these cases.
Yes, when the divisor is linear. So if you, it's always going to happen in a question like this, factor question. You can't use synthetic if, for example, you're dividing this by x squared plus 4 or something. Then you have to do long division.
Oh, this is so dumb how like the technique is literally guess and check.
Yeah.
I don't even know. So then after that, you just do synthetic with that with
Yeah,
negative.
just this, yeah, just the -2, you do synthetic, and to know if you've done it right, you know, because this is a factor, the remainder has to be 0. So if you do it right, your remainder down here is going to be 0. So how do we do this? You first bring the 1 down, okay, and then you multiply this by -2, then you add them. Up to down you add, diagonal you multiply.
Mm-hmm. And yo, how would I do synthetic again if I have a fraction?
So like if you had 3x minus 2, if you're dividing by this,
Yeah,
you
like that.
solve for x, set it equal to 0, and you solve for x. And then you put 2 out of 3 here.
And then you reduce at the end.
Yeah.
And you don't reduce the remainder, correct?
Yes. Oh yeah, you were doing this last time as well, right?
Yeah, I was doing that, and then our teacher changed, so we just started at lesson unit 2.
Here, look at this. So this is this factored, right? So finally we have this cubic thing as x plus 2, and the quotient here is x squared minus 7x plus 12, yeah?
Mm-hmm.
And now this is a quadratic. We can factor that even more. How do we
Can you
factor that?
explain it?
Yeah, just man it, right? It's just gonna become, if you're quick with this, it's just x minus 3x minus 4.
Bro, I think, and then you just put the zeros in.
Yeah, now you're done. So at 3, at 4, and then at -2. So -2 right there. And you know your y-intercept is positive 24. And then you kind of just connect the dots.
That's of degree 6, so.
This is of degree 3.
Oh, degree 3.
Mhm. If it's a graphing question, they won't ask you for more than degree 5.
Wait, can you show me like what would 5 look like? Just like not like this one, just like the rough sketch of 5.
So 5, the parent function looks like this, just like a cube. Okay, but in practicality, 5 would look, it'll just have 2 more turning points. So x to the power of 5 would look like this. So it has 1, 2, 3, 4 turning points.
And how would I know them?
The turning points?
Yeah. Is that like the same technique we were using before?
Yeah, yeah. So you'll just find the zeros and you'll find the local maximums and minimums between them.
So that's cubic, and then 4 is like a W.
Yeah, 4 is like, well, the parent function is
Yeah,
just
it's
like
just
a
the parent
quadratic. Yeah, but in practicality, you'll see like this, like a W, if it's positive.
Okay, so Other than that, I think we did all of them.
Mhm.
Okay, I think today, like, I think I'm good just for the 30 minutes because I didn't have that much to ask you.
All right, that's good.
Thank you. Huh?
Yeah, no worries then.
See you. Bye.
Bye bye.